All right, so as I alluded to a couple days ago, that lesson had a bit of a bittersweet moment to it because it was the end of pretty much three whole units dedicated to triangles and how we're going to start to shift the focus to some different shapes. Today being the first one. Now you're probably saying, well, Josh, there's a triangle on this set of notes. There's a reason for that. A lot of the other stuff that we incorporate actually have triangles pop up inside the shapes, the new shapes that we introduce. But in terms of just talking specifically about triangles, those days are behind us now. So this unit primarily is going to focus on shapes that fall under the category of quadrilaterals, which are four-sided shapes. But today's kind of an introductory lesson for polygons in general. Polygons meaning, well, shapes, enclosed shapes. And as you change the number of sides, most of them usually have a unique name. And we're going to look at some of the properties attached to them. So first off, first thing we're going to take a look at is what's known as the interior angles sum. This is just kind of a rule that we're going to apply, and we're going to use a table here to kind of calculate some of these. So it says that the sum of the degrees in any polygon can be determined by the number of triangles that can be drawn within that polygon. We're going to complete the table below, looking for a pattern first that is going to actually help us create a formula towards the bottom here in order to calculate the sum of the degrees in any polygon. So again, we're coming off of triangles. You add up all their angles, we know it equals 180 degrees. Because we know that to be true, we're going to use that fact, drop in some triangles in these other shapes, and be able to calculate what's going on here. So first one, our old friend here, triangle, number of sides, of course, will be 3. How many triangles make up a triangle? 1. It is the triangle. And we know the sum of all the interior angles of a triangle equals what? 180. So no surprise there. So then we move on to the next one. So going from triangle to quadrilateral, how many sides does it have? 4. It has 4 sides. And it's kind of done some of the work for us. In that shape, how many triangles has it been divided into? 2 triangles. And if you were to think about that, if you were to add up all the angles of one triangle, which we know is 180, plus all the angles in the second triangle, which is another 180, how many degrees does that give us?
360.
360. So then we keep on moving. A pentagon has how many sides?
5.
5. And it's been divided up into how many triangles?
1.
Oh, careful.
1, 2, 3.
3. Well, if there's 3 triangles now, each of them contributing 180 degrees, how many total degrees does that give me? 540. Next up, we have a hexagon,
6.
which is 6-sided, split up into how many triangles?
4.
4. And so each of those triangles contribute 180 degrees for a grand total of 720 degrees. Now, here's where the diagrams start to stop, because hopefully we're starting to notice a pattern. When we add another side, so in this case, a heptagon has 7. How many more triangles are in there?
5.
A total of 5, because it increases by
1.
1. Add another side, you add another triangle. Well, every time you add another triangle, how many more degrees do you add to it?
180.
Another 180. So I think this one should be 900.
Yep.
And then just to kind of complete this table here, an octagon has 8 sides for a total of 6 triangles for a total of 1080 degrees. A nonagon has 9 sides which is divided up into 7 triangles for a total of 1,260 degrees. And then a decagon has 10 sides for a total of 8 triangles,
1440.
which is 1440, 1,440 degrees. Now, we're going to stop at decagon for now because this pattern will continue. You add another side, it adds another triangle, which adds another 180 degrees. So every new side you add, one way or another, adds 180 degrees to your total. So there is a formula which has actually been defined, and we're going to try to piece it together ourselves, saying that if n represents the number of sides of a polygon, then the sum of the interior angles, which we're going to denote with a uppercase S, can be found using the formula. Well, I'm going to start with S equals. Did anyone notice a pattern in terms of the number of sides versus the number of triangles? So for the angles, there was a multiplying by 180. We took the number of triangles times 180. Perfect. How do we know how many triangles are in it? Based off of the number of sides.
Go by 2.
There's a difference of 2, right?
Mhm.
There's 2 more triangles or 2 fewer triangles than the number of
2
sides.
more.
Careful. So an 8-sided shape
2
has,
fewer.
there's 2 fewer. So if you think about it, if you were to take the number of sides minus 2, will that give you the number of triangles that are in that shape?
Yes.
Okay. I'm going to wrap that in parentheses. If you were to take that value, which is giving me the number of triangles, and then as Shanitha said, multiply it by 180, would that give you the total number of degrees?
Yes.
So there's our formula. If you at least know how many sides it has, drop that in for your value n. That's going to give you how many degrees are in that shape. All right, so we developed a formula here after noticing a pattern. That formula is going to be used throughout the rest of today's lesson as well. Just kind of help us find specific values we're looking for. Now, there is another formula we have here, which helps us find a single interior angle of a regular polygon. Now, I'm going to highlight this in both spaces here. Regular polygon. Regular polygon. So what a regular polygon is a shape with however many sides it may have, but every one of those sides is congruent. So for example, our regular polygon for a quadrilateral would be a square. All 4 sides are the same. For a pentagon, we would literally think about our nation's pentagon, where all sides of the building are the same length. Gives it a very regular kind of uniform shape. The shapes up here, these are examples of regular polygons for each of the examples that it showed here. Each of those sides are congruent to the others. Now, that's what it means to be a regular polygon. In order to find, excuse me, one of those angles, it says that a regular polygon is one in which all sides are equal. Therefore, all angles are equal. Hopefully this doesn't surprise us too much, because again, if we go back to our comfort zone, which is probably still triangles, when we had an equiangular triangle, it was also equilateral, because the angles had a very, very strong effect on what the sides opposite them ended up doing. So very, very consistent relationship there. So if all the angles are the same, all the sides are the same. If all the sides are the same, all the angles are the same. So what that allows us to do then is to find the measure of one of those interior angles. Since they're all the same, we just need one. We can use the formula S from up above. So the sum, the total sum, divided by the number of sides. So again, if that's like, I don't know what that means, underneath here, I'm going to write a little note for it. This is just the sum of interior angles divided by the number of sides. Which hopefully doesn't surprise us too much, because if you think about it, if you know the total of all the angles and you know each of them are equal to one another, to divide them equally, you would just take the total of the degrees divided the number of sides. So two handy formulas for us to use there. Those are going to prove quite useful. So we're going to do some practice examples here. So number one asks us to find the sum of the interior angles of a 15-gon. So off to the side here, 15-gon, that's just telling me that the number of sides is 15. And it is asking me for the sum of the interior angles, not a single interior angle. It is asking me for the sum. So we have a formula for that. S equals, and then in parentheses, the number of sides, which is 15, minus 2, because that gives me how many triangles are in that shape, times 180. Well, 15 minus 2 is 13. 13 times 180 gives me a total of 2340. 2,340 degrees is the grand total of all the angles in a 15-sided shape. Number two, same thing, finding the sum of the interior angles. Always make sure you read carefully what it's asking you to find. This time we have a 21-gon, which just means the number of sides is 21. I think there might be a special name for it, but 10 is where I stop.
3420.
Too fast for me, Missy, but you are correct. So if I dropped it into the formula here, I would have 21, which is the number of sides, minus 2 times 180. And Misty said that the total is 3,420 degrees. Then we move on to number 3 here. What is the measure of each interior angle of a regular pentagon? So each interior angle, which if it's regular, when we find one, we find them all, right? And then it says of a pentagon, which has how many sides? 5. So here n equals 5. Before we can find each angle, we need to find the total. Now times 5. Don't forget your formula. S equals 5 minus 2, because it's not based off of how many sides it has. It's based off of how many triangles are in it. And that's always 2 less than the number of sides. Then that's what we multiply by 180. So I get that the total
540.
is 540 degrees. Now, we're not looking for the total, but we did need it in order to find the next step.
Divide it.
Divide it by what?
5.
By 5. So in this case, we need the total divided by the number of sides. In our case here, the total is 540 degrees. We're dividing it by the number of sides, which is 5. So what are each of those angles going to measure as?
108.
108 degrees each. So I would say each angle is 108 degrees. 5 of them together make the total of 540 degrees. Number 4, similar situation here, asking again for the measure of each interior angle of a regular 18-gon. So that one doesn't have a fancy name, but it does tell me that the number of sides is 18. So I need to find that total first. Plugging into my formula, I do 18 minus 2. And then that result will then be multiplied with 180. Which gives me a total of 2880, 2,880 degrees. Almost at 5, didn't you?
Yeah.
Yeah, good. So remember, the number of sides does change as well. So we take 2,880 divided by 18, which gives me 160 degrees. Now remember, this only applies to regular polygons. There are things known as irregular polygons, where the sides aren't all congruent. They're still considered a, quadrilateral, pentagon, things like that, but it's not considered regular unless all sides are the same. So we had a trendy little formula there that helped us with 2 formulas. We could find the total sum of all the angles in any sided shape. And then as long as that shape was a regular polygon, we could then figure out by dividing it by the number of sides or angles, if you wanted to, what each of those would have to be in order for them all to be the same. Now, similar to what we did with triangles, we're going to talk about an exterior angle. We first introduced the idea of an exterior angle way back when we introduced triangles to begin with. And that was when we said the exterior angle equaled the sum of the 2 non-adjacent angles. Here we're doing something a little bit different. Instead of just looking at one exterior angle, we're looking at what happens when you do an exterior angle off of all the vertices. So it says here, just as a reminder, exterior angles are always supplementary to their adjacent interior angle. What does it mean to be supplementary? Oh, that's complementary. Supplementary is 180 degrees. I don't know if I can squeeze this in very well. Supplementary means 180 degrees to their adjacent interior angle. So on the polygons below, we're going to do a little mini exercise, see if we can discover a pattern here like we did on the front. To go from there, we're going to start with our longtime friend, the triangle. And we're going to calculate each of these exterior angles. Notice that each of the interior angles are different, which means the resulting exterior angle is going to change as well. So I'm going to start at the top, 79 degrees. We know that its exterior angle and 79 degrees has to be supplementary. So how would you figure out what's left? 180 minus 79 gives me 101. I'm going to go clockwise. I'm going to come around to the 40-degree angle. Take 40 degrees out of 180. You're left with 140 degrees. And then working around to the last one there, take 61 away from 180. You get 119 degrees. Now, we're not interested in each of them individually. We're interested in their sum. So what's 101 plus 140 plus 119? 360 degrees. So again, I haven't given us a formula. We're calculating these by hand here. so far on exterior angles. We're hoping to see a pattern. Jumping over to quadrilateral, same little exercise. This time there are 4 exterior angles to kind of work our way around. I'm going to start kind of up there by that 124 degrees. Its exterior angle would be 56 degrees. Then going clockwise from there, the 76 degrees has an exterior angle of 104 degrees. Down to the 89, 91 degrees is its exterior angle. And then over to the 71, I believe it's 109. Add all 4 of those together. 360. Do what? Maybe. For the sake of time, I'm going to help you with the calculations here real quick. If you guys want to just make sure they add at the end. I'm going to start at the 98-degree angle, work my way clockwise from there. The exterior angle should be 82 degrees, 59 degrees, 93 degrees, 50 degrees, and 76 degrees. Now I just need the sum.
$360.
360. Maybe Shanitha's right.
Yeah. Should we even do the other one?
Just for the sake of our notes, I'm
Okay.
going to jot them down real quick. I'm going to start up there next to the 129-degree angle and go clockwise again. The exterior angles then should be 51 degrees, 56 degrees, 68 degrees, 57 degrees, 63 degrees, and 65 degrees for a grand total of 360 degrees. So, did you notice what was happening to the exterior angle measures the more angles we had? They lessened because there was, if the grand total is always going to be 360 degrees, that means there's less left over as you add more angles.
Certain ones got higher too.
So some of them got a little bit higher, and that was, but if you looked at it on the shapes that you had a noticeably larger angle,
Yeah.
there was one that was also noticeably smaller. So it kind of always offset itself to make sure that that total always turned out to be 360 degrees. So our conclusion can be that the sum of the exterior angles of any, emphasis on any polygon is 360 degrees. So little mini practice. We had one for interior angles. We're going to have a little one here for exterior angles. Let's try to be careful not to confuse the differences between them. This one's a little bit easier though, because it was always 360. We don't have to do an extra calculation like we did above. We do want to still make sure we're reading the prompt carefully. So number 5 says, what is the measure of each exterior angle of a regular hexagon? First off, it is regular. That is important. That means all the interior angles are the same. So would it make sense then that all of its exterior angles would be the same as well? Okay. How many sides does a hexagon have?
6.
So number of sides equals 6. How are we going to figure out what each of those exterior angles are? Divide the 360 by the 6. I knew what you're meaning. You just said them backwards is all. So again, we know the total of the exterior angles is 360 degrees. If all the exterior angles have to be the same, since it's a regular shape, we'll divide that by 6 to get a total of 60 degrees each. Number 6, very similar process. Again, asking for each exterior angle. So it is important that we know that it is a regular 24gon. So again, not a cool name, but at least it tells us how many sides it has. How am I going to calculate the measure of each of those angles? .360 divided by 24. 15 degrees, which hopefully doesn't shock us too much, because as we kind of started to notice a pattern up above, the more angles or sides, therefore angles, there are, the less each of those angles can be if the total is still stuck at 360 degrees. And that total is only for the exterior angles. Interior, those change, those increase. Exterior, stuck at 360. Now, the last two are slightly more advanced because it requires us to interpret what information we actually have. So it says, excuse me, if the exterior angle of a regular polygon, so it's that way we know they're all the same, measures to be 12 degrees, how many sides does the polygon have? So how many sides? That means we're missing n, right? Now, if we had known how many sides it had, what would we have set up in order to find the exterior angle?
Divided by 360.
Well, divide 360, yeah, by it. So we would say that we would have taken 360 divided by the number of sides. And in this one, we actually had that measurement. Yes. So this time we actually had the exterior angle measurement, which was 12. Can I solve for n? Sure. This is kind of like those invert or those trig functions we had earlier, where that variable got trapped in the denominator. I would get it out of there by first multiplying both sides by n. I'm gonna actually write this over here. That gives me 12n equals 360. How would you then solve that? Not
Divide
minus.
it.
If it's beside it, we actually end up dividing it. So we're going to divide that 360 by 12 to get that n equals 30. Now, is that 30 degrees? Or what did n represent? The number of sides. Number 8, very, very similar. If you want to try this one out, I'm just going to give you the answer so you can practice later if you wish. The number of sides you should end up coming up with is 9. All right. So on our third page here, oh, sorry. No, you're fine. Is there one you need me to zoom in on? Number 7. So while he's jotting that down, there's actually a relationship here. If you were to follow this same process, you'll notice a pattern when you're trying to figure out how many sides there are. You actually end up taking 360 and dividing it by the exterior angle measure instead of the number of sides. So it's actually pretty interchangeable. You can use it either to figure out every one of the angle measures, or you can flip it and say, well, instead 360 divided by that angle measure will give me the number of sides. So that's going to be one of the things we actually write here on this little quick formula review. This will be a handy little thing to keep nearby as you work on the assignment later today, that has all the formulas that we've more or less used or stumbled across in our process thus far. So in order to find the sum of interior angles of a polygon, that is S equals n minus 2 times 180. In order to find the single interior angle of a regular polygon, you just take that total S and divide it by the number of sides. What about the sum of the exterior angles of a polygon? What's the formula there? Nope, the sum of the exterior angles is just 360. There is no formula. It just is. Now, define each of the exterior angles of a regular polygon. Missy, I think that's what you were working towards.
Yeah.
That's where you take the 360 and you divide it by the number of sides. And then the last one, that's one we were just kind of briefly talking about. We never actually explicitly wrote it down. But if you wanted to find the number of sides of a regular polygon, you would take 360 and divide it by the measure of an exterior angle. So all these formulas are going to play a role here on the following practice questions, and we have a variety. We won't get to every single one, but I want to make sure we jump around a little bit. Make sure we at least see a handful of each. That way you're ready for the assignment practice questions today. Be careful. Make sure you're reading it to see what type of angles you're looking for, whether they're interior versus exterior, because that changes your approach. Also, make sure you're checking to see whether they're regular polygons or not, because that can affect our answer as well. So number 1, what is the sum of the measures of the interior angles of a pentagon? So sum of the measures of the interior angles, and the shape is a pentagon. So that means it has 5 sides. We want the sum of the interior angles. So we're going to use the first formula we wrote down up above. So S equals the number of sides, which is 5 minus 2 times 180. What do you end up getting for the total?
540.
540. Which technically we already calculated that on the first page, but it doesn't hurt to try that formula out again. Number 2, same exact process. All that's changed is the number of sides. So I'm going to give you this answer. If you want to check it for me, you're more than welcome to, but the total sum of all the interior angles of a 27 gon should be 4,000 500 degrees. Number 3, find the measure of each interior angle of a regular octagon. It is important that it's regular because if it wasn't, there's no guarantee that every angle would be the same. So for this one, what do I need to find first? Octagon has 8 sides, in case you've forgotten. In order to find each measure, I'm going to need the total first. Oh, careful. These are interior angles. So S equals 8 minus 2 times 180. So the total of all the interior angles, I believe, is 1080 degrees. Now, that's not our answer. That's just helping me get to my answer, because if that's the total, and then we want it divided evenly amongst the sides, or the, excuse me, the angles.
Divided by 360.
Careful. By what?
By 8.
By 8. You're okay. It's the end of the week where we just came off of a test yesterday. Our brains are ready for a break. So I think you get 135 degrees. Number 4, almost an identical process. So I'll let you, if you want to try that one on your own, I will tell you that each interior angle for this one is 162 degrees. And if you kind of want to do a little mini exercise there, you're welcome to it. Okay. Next one, a little bit different in terms of the information that is asking here. So it says that the 5 angles of a hexagon, how many sides does a hexagon have? 6. So the 5 angles of a hexagon measure 119 degrees, 129 degrees, 104 degrees, 139 degrees, and 95 degrees. What is the measure of the 6th angle? Well, to know that, we need to know 2 things. First off, let's focus on the information we're provided. How many degrees do we have out of 5 of the 6 angles thus far?
Yeah, 5 of them.
We have 5 of them. We need the 6th, but I need to know that total first. I need to know how many degrees we currently have before we then figure out what's missing. So right now we have 586 degrees in our hexagon. Well, that's only half the information I need. In order to figure out what's missing, I need to know how many degrees there's supposed to be. Ooh, careful, we're on interior angles. So to find the total, we would take S equals 6 minus 2 times 180, which means the grand total, I think we calculated this on the front, I believe it's 720. So what we know now is in a hexagon, there should be a 720 degrees. We only have 586 degrees.
Divide 720 by 586.
We need to subtract
No,
because
okay, yeah.
we have the total and we have what we we're looking for what's missing, we have part of it. So we need to just find that difference. So we would then take 720 minus 586 degrees. And we get, I believe, 134. Now, just for the sake of our notes, I'll write that this is the sixth angle. We had 5 of them, we needed the 6th. So we knew what we needed, we knew what we had, we figured out what was missing. Next one, flipping us upside down again here. It says the sum of the interior angles of a polygon is 1,620 degrees. How many sides does the polygon have? This is a little strange because now it's actually given me the sum of the interior angles as 1,620 degrees, and it's asking me how many sides does it have. So do I know N?
Yeah.
Hmm.
No.
If it's asking me how many, I must not know it yet. So that's what I'm looking for. So hopefully I know something that I otherwise wouldn't have known. And in this case, that's the sum of the interior angles. Well, I had a formula for that. It said that the sum of the interior angles equals n minus 2, and then all of that times 180. Well, that's convenient because I know the sum is 1,620. I don't know now. If you've had me in the past, normally at this point we would distribute the 180, but that's going to give me more things to move. Can I break that 180 off first? It's being multiplied, right? I could divide both sides by 180. So I think you get 1,600. I got 9. 1,620 divided by 180. So 9 equals n minus 2. And I'm going to clean up my notes here because otherwise it'll drive me crazy. Which means if I bring this over here, 9 equals n minus 2. How do you finish solving this one?
Get the n by itself.
Get n by itself. And to do that, all this, yep, add that too. So I get 11 equals n. So in order for the total of the interior angles to be 1,620 degrees, that must have meant that this shape had 11 sides. So as with most things in math, a lot of times, especially when equations and formulas are involved, you need to ask yourself 2 things. What do I already know? What am I trying to know that I don't know yet? So what you're trying to find, that's going to be your variable. What you already know probably can get dropped into some sort of formula somewhere, as long as you take the time to recognize what it is that you have. Now, next one, almost identical. So I'm going to give you the answer there for that one if you want to try it on your own. This particular one, this shape should end up having 24 sides. Number 8, what is the sum of the measures of the exterior angles of a nonagon?
300.
I think I heard it.
There's the right sides.
It does have 9 sides, but we're getting ahead of ourselves. Some of the measures of the exterior angles, if I look at that little review box at the top of this page, it is 360, yes. So again, sometimes, and especially when it's thrown in the mix of these other problems, sometimes we stop to pause, we fail to pause, read it carefully and think, oh, this is just 360. Doesn't matter how many sides it has. Some of the measures of any polygon, the measures of their exterior angles will always be 360 degrees. Number 9, though, this one actually has me using a little bit of work. It says, what is the measure of each exterior angle of a regular, it's important that it's regular, 20-gon. So that means it's got 20 sides.
Is it 360 divided by 20?
It is absolutely 360 divided by 20. Because we know that the sum of the exterior angles is always 360. If there's 20 of them and we have to divide them evenly, well, we just
18.
do exactly that. You said 18?
Yeah.
18 degrees. Not bad. On a roll. I'm gonna do number 10, but I'm gonna leave well. Nope, I'm gonna do both 10 and 11 because 11's sneaky. So 11 says, if the exterior angle of a regular polygon measures 9 degrees, how many sides does the polygon have? So we're solving for n. But we're actually giving the measure, so the exterior angle, a regular polygon measures 9 degrees. I seem to recall on the previous page, there was one that said the number of sides of a regular polygon, all we had to do is take 360 and divide it by one of the exterior angles. So 360 divided by 9 equals 40. 40 sides. Just imagine what a shape like that would even look like. Oh, I'm actually really proud of you for saying that, in fact, because there's a debate as to what is a circle. We say a circle has no sides, it just is. But how do we know that our eyes just aren't tricking us and that it has just infinitely many sides? Because the more sides you add, the more circular it does look. I said I wanted to do number 11 simply because this one is very sneaky. Because what it gives me is the interior angle of a regular polygon measures 108 degrees. Less emphasis on interior angle. If I look back on the previous page, I said that in order to find the number of sides, you need to divide by not the interior angle measure, you need to divide by the exterior angle. So this one tried to trick me. It almost made me want to do 360 divided by 108. No. I need to figure out the exterior angle that would be attached to a 108-degree angle. Well, earlier in our notes, we said that an exterior angle and its adjacent interior angle are always supplementary, which means my exterior angle is going to equal 180 minus the interior angle 108. So my exterior angle going to equal what? 72 degrees. Now I'm in business. Now I know the exterior angles because now I can use that formula from the previous page that says that's just 360 divided by the exterior angle. Turns out all the angles on this one is 72 degrees. Exterior angles on this one 72 degrees, which tells me that it is a 5-sided shape. Or in other words, a pentagon. So be careful. Every once in a while, there's a sneaky one that slides in there. Because when you're reading a bunch of angles, sometimes your eyes glaze over and you don't see interior and exterior as being different things. They all start to look the same. All right. I'm actually going to, just for the sake of complexity, I'm actually going to skip 12 to do 13. They both will solve similarly. I will tell you, though, that this one should end up being x equals 116 degrees. If you want to go back and try this one later, you're more than welcome to. Maybe you already know what to do there. I instead want to take a look at this one and try to find x. Now, we need to figure out where x is. It's right here. It's an interior angle. Any ideas? How can I find that measurement? Ooh, careful. 360 would work if we're talking exterior angles. Interior angles change the more sides it has. So would it help to know how many degrees should be in here to begin with? So that's going to be my first goal. So what I'm going to do first is say the total. What's that? I didn't even count it yet. 1, 2, 3, 4, 5, 6, 7. Yes, heptagon. Ah, did you look at our front table?
Yes.
Good job reusing information we had. I like a good shortcut, especially if it's based off of work we already did. So we know what the total should be. What is currently in there right now? Careful, I got a different value. Well, first off, what's the little box mean? 90 plus 148 plus 140 plus 136 plus 142 plus 150. I got 806. If someone wants to check me on that one.
I got it as well.
You got 806. Okay. So we know there should be 900. We're going to take away the 806 degrees that are already accounted for, which leaves me with 94 degrees remaining to be my x. We're doing fairly well for time. I'm going to do 14. I'm going to skip 15. I'll give you parts of the answer in case you want to try it. And then I'd like to try to get to 16 and 17. So make sure you're always reading what it's asking you to find, because this one is asking us just to find x. The next one is actually asking us to find one of the angle measurements, which means we would use x in that case. But for this one, I have a lot of information, but they're all interior angles. How many sides does this shape have? 6. So if I look at the front side, do we know the sum of what the sum should be? 720 for a hexagon. So off kind of to the side here, just as a side note, S equals, you said 720? So we know what it should be. But unlike previous ones, aside from just two of the angles where we have 110 degrees and 116 degrees, our X is scattered everywhere. That's okay, because if we take it for what we know should be, shouldn't it be true that if I add all those angles together, regardless of what they look like, it should still equal 720? Should. So I'm just going to start, let me see here. I'm going to start at the 8x minus 1. That's one of my angles. And I'm going to work my way around clockwise to say that, where do I need to write this? Okay. 8x minus 1 plus 5x plus 36 plus 116 plus 7x plus 19 plus, I get tired of saying that, 6x minus 2 plus 110 should equal 720. Now, that looks like quite the mess until you pause for a moment and realize, well, there's just a ton of like terms in there begging to be combined. So if I was to go through there very carefully, I see an 8x, a 5x, a 7x, and a 6x, which all add together to give me 26x. And then I go through, and I'm not going to, I don't think I need, well, maybe I should. I have -1, 36, 116, 19, -2, and 110. If I add all those together, I get 278. And that should still equal 720. So it looked really bad at first until I did a little maneuvering there. Now it's just a two-step equation. And subtract 278 from both sides. It's 26x equals 442. Divide both sides by 26. X equals 17. Now, was that all we were looking for this time? Yes. It just asked us to solve for X. Now, number 15 is going to make you go a little bit further, but because there's fewer parts, I'm okay with leaving this one for you to try later. But I am going to give you two key pieces of information to make sure you're on the right track. First off, put it down here in the corner. As you're solving this one, you should get that X equals 9. But then make sure you don't stop there, because it's not actually asking you to find X, it's asking you to find the measure of angle B. And as you progress a little bit further, using that X, you should find out that the measure of angle B should be 79 degrees. Again, that one has fewer parts, so I don't feel too bad letting you work through that one yourself. Number 16. Number 16 is really forcing us to use our visual cues here. It's asking us to just solve for X. And it only gives me an X in one of the angles. But what other information does it give me?
10 sides.
It has 10 sides. Does it? I didn't actually count yet. Yep, 10 sides. So do we know what the total should be?
1440.
1440, because it's a 10-sided shape. Okay, so we know where we're going. Problem is though, I don't have something for every single angle. I only have one of them.
Would you plug 1440 into the X?
No, because if I plugged it into the X, that means that that is my X. At which point I would say, well, boom, we already have it. Oh, go ahead. Oh, careful though. That one angle equals the whole total.
Would you divide it by 1440?
I like that we're dancing around. I appreciate your guys' candor, but this one, we're overlooking something glaring us right here in our eyes. What are on
They're
those?
congruent.
They're all congruent. If all the sides are congruent,
All the sides. Well, I mean, angle.
all the angles are congruent. So that means that all 10 angles
Are 10x
are
plus
10x
4.
plus 4. So if there's 10 of them, I'm going to write it as 10 times 10x plus 4 because there are 10 of them. That saves me from writing 10x plus 4 plus 10x plus 4 plus 10x plus 4 10 times. We just do 10 times it. And that should equal what total again?
1440.
1440, 1,440. This one's going to be a little bit more friendly for us. It's up to you. Do you want to distribute or divide? Distributing here wouldn't be too crazy. I'd get 100x plus 40 equals 1440. Finish solving, I'd subtract 40 from both sides. 100x equals 1,400. Divide by 100. I believe we get x equals 14. Is that correct? Sometimes we just got to take a step back and look and say, you know what? Those things look familiar. I remember what they mean. And then it helps us work through that process. All right, last one, slide adjustment here. All the ones so far on this page have really, well, most of them anyways, have been all about interior angles. This time we have information for exterior angles. This makes my job a little bit easier because do we know what they add up to equal? 360. Exterior is always 360. That does mean we have to write all of these out, but at least we know what the total is very quickly. So I'm actually going to start there at the top with the 5x plus 4. So the sum of all of them should equal 360. So 5x plus 4 plus 4x plus 9 plus 9x minus 6 plus 4x plus 1 plus 7x plus 4 should equal a grand total of 360. Now, very quickly, I would suggest going through checking for those like terms. So I see 5x, 4x, 9x, 4x, and 7x, which for the sake of saving a little bit of time, if someone wants to check, I got 29x. And then going through, I've got 4, 9, negative 6, positive 1, positive 4. I got 12. Still should equal 360. Go into solving this two-step equation. Subtract 12 from both sides. $29x equals, I think I heard 348. Divide both sides by 29. X equals 12. And was that what I was asking for? Good. So we're done. So a couple quick reminders. At the very, very least, I would make sure you have this handy as you're working through the assignment today. Second thing I would warn you about is read carefully. There's a big difference between interior angles and exterior angles.